Hello, and thanks for clicking on this next Knowledgeable One production. Today, we're going to talk about systems of equations with word problems. Okay, so we've already talked about a couple of these. Let's keep it going, and we'll review it in case you're still having trouble. All right, so we have Kristen. Kristen spends $131 on shirts. Fancy shirts cost $28, and plain shirts cost $15. She bought a total of, that should say 7 shirts. Then how many of each kind did she buy? All right, so that's what I want to know. Now, you might be able to figure this out without, doing a system of equations, but we'll do it with a system of equations so that you can see how it all works. All right, so the first thing I want to know is I need a couple of variables here, so I need to know what I want. I want to know how many of each kind she bought. So I'm going to let F be the number of fancy shirts that she bought. And P is the number of plain shirts that she bought. Okay, P is the number of plain shirts that she bought. All right, so now I'm going to try to come up with some equations that involve the number of fancy shirts and the number of plain shirts. Well, the first thing I know is that she bought a total of 7 shirts. So the number of fancy shirts and the number of plain shirts together have to be 7. The other thing I know is that, well, I know what the deal is with money here. I know it's $28 for a fancy shirt, and then it's $15 for every plain shirt. And in total, she spent $131. There are my 2 equations. Okay, so now I need to solve these 2 equations. The 2 methods that I would suggest would be substitution or elimination to use on these. All right, I'm going to do the first one here by elimination. Okay, just to practice it, to review it. All right, so if I want to eliminate one of the variables, I need the set of variables to add up to 0, right? So right now, neither one of those variables do that. So I'm going to have to multiply one of the equations by something. All right, so I'm going to choose to eliminate P. Okay, that's the variable I want to eliminate. Right now it's 1P and it's 15P. So I'm going to have to multiply the top by negative 15. Right? Got to multiply the top by negative 15 because on the top, that will then give me a negative 15P. And then I'll keep the positive 15P underneath in that other equation, and they'll knock each other out up to 0. All right, so let me fill in the rest of this. We have negative 15F minus 15P equals negative 105. And then we have 28F. The bottom equation I'm not going to change. I'm going to keep it the way it is. Equals 131. So now I'm going to add these 2 equations together. So negative 15F plus 28F is 13F. Negative 15P plus 15P, they eliminate each other. They're 0. And negative 105 plus 131 is 26. Okay, so now if I divide both sides by 13, I get F equals 2. So I bought 2 fancy shirts. All right. Now, the question is, how many plain shirts did I buy? All right, so now you could take F equals 2, plug it into one of these 2 equations, solve for P, okay? But look, let's just be honest here. She bought a total of 7. If she bought 2 fancy shirts, then that means she had to buy 5 plain ones, right? Because she bought 7 total. Okay, so our conclusion is 2 fancy shirts and 5 plain shirts. And that's our answer. Okay, we're all done. All right, let's try another one. Okay, now we have a class of 195 students that went on a field trip. They took 7 vehicles, some cars, some buses. Find the number of cars and the number of buses they took if each car holds 5 students and each bus holds 45 students. All right, so the first thing we want to do is figure out some variables. What do we want to know? We want to find the number of cars and the number of buses. Okay, so I'm going to say C is the number of cars, and B is the number of buses. All right, C is the number of cars, and B is the number of buses. Okay, so now I know that in total they took 7 vehicles. So some cars and some buses. So I know that C plus B, the number of cars and the number of buses together, is equal to 7. And I also know 195 students went on the trip. Okay, but each car only holds 5 students. So 5 students can fit in every car, plus 45 students can fit in every bus, and together there's 195 students all together. Here is a system of equations. C plus B equals 7, and 5C plus 45B equals 195. Now, I want you to take that equation and I want you to solve. I need you to solve it for C and I need you to solve it for B. Okay, it's your choice for how you do this. You could do it by substitution. You could also do it by elimination. It's up to you. All right. I'm going to do this by elimination again, only because that's the thing we've been practicing recently. So I want to eliminate one of these 2 variables. Let's see. I can eliminate either C or B. I'm going to choose to eliminate C. I think it's easier. You got to multiply by a smaller number. I need to multiply the top by -5 because I don't have a -5C on the top and a 5C on the bottom, and they'll add up to 0. So we'll have -5C minus 5B equals -35. And underneath, we're going to keep the bottom equation the same. And now we're going to add these 2. Here we go. So -5C plus 5C, that's 0. They literally knock each other out. 45B plus -5B is 40B. And then 195 plus -35, or 195 minus 35 is 160. So if I divide both sides by 40, I get B equals 4. So I know I know the number of buses is 4. Now, I need to know how many cars. Again, you can take B equals 4, plug it into one of these equations and solve. But look, they took 7 vehicles. 4 of them were buses. So how many of them were cars? 3, because that adds up to 7. So the number of cars is 3. 3 cars, 4 buses. And there's your answer. All right, and we have one more. Jane has a total of 36 coins that total $3. The coins are all nickels and quarters. How many of each coin does she have? Okay, so what do I want to know? I want to know how many nickels and how many quarters. So N is going to be the number of nickels, and Q will be the number of quarters. All right, so what do I know about the number of nickels and the number of quarters? I know that in total, there's 36 of them. So N plus Q has to be 36. And now, I know that the number of nickels and quarters together make $3. So I need to know how much a nickel and a quarter represent. So a nickel is 0.05 times the number of nickels plus 0.25 times the number of quarters. Together, that's $3, or 3, right? 3.00 or $3. Okay, now I need to solve this for N and Q. Okay, so there's a couple of ways I can do this. Again, you could do it by substitution, you could do it by elimination, however you want to do it is fine. I'm going to do this last one by elimination again. So I'm going to multiply the top equation by, I'm going to multiply it by -0.25. Okay. All right, I'm going to eliminate Q. So that gives me -0.25N. If I distribute, whoops. -0.25N minus 0.25Q equals -0.25 times 36 is -9. And then the bottom equation, I'm going to keep it the same. Q equals 3. I'm not going to write 3.00. I'm just going to write 3. All right, now I'm going to add these two equations together. Here we go. Negative 0.25n plus 0.05n is negative 0.20n. Negative 0.25q plus 0.25q, they knock each other out. Negative 9 and 3 is negative 6. And now I'm going to divide both sides by negative 0.2. And I get n equals 30. Okay? So the number of nickels is 30. Now, how many quarters are there going to be? Well, there's 36 coins total. 30 of them are nickels. So the number of quarters has to be 36 minus 30. So it's 6. So the number of quarters are 6. What does this mean? It means that if you had 6 quarters and 30 nickels, you would have a total of $3. Okay? And there is your third problem. All right. As always, thanks for clicking.